Hello guys, so today we're going to start learning about acids and bases. I'm going to introduce several different concepts to you about acids and bases, and then throughout this unit we'll come back through some of these again and go over them in more detail. Okay, I just kind of want to expose you to everything right now. So let's just go ahead and get started and jump right into it. So let's start talking about acids. Okay, so acids are substances that tend to taste sour. They turn litmus paper red. Their pH is less than 7. So if we look at this example here, which I got this image off of Wikipedia, lots of things that we eat are acidic. Okay, so look at all these things that are listed here. Lots of them are acidic. So many food products tend to be acidic. Not all, but many. And acids are typically compounds that start with hydrogen as the first element in the chemical formula. Okay, so hydrochloric acid, sulfuric acid are the two examples I gave you there. Okay, now acids and bases always exist in water. Okay, so they're always aqueous. They're always things that are aqueous. And as we've learned before, things dissociate in water. Polar and ionic things dissociate in water. So these acids are all polar covalent molecules, but they will actually split up as if they were ionic. Okay, so look, for example, here, hydrochloric acid, when it's in water, it splits up into the hydrogen ion and the chlorine ion. Okay, now one thing about the hydrogen ion I want to point out, if you remember from first quarter, okay, hydrogen is one proton and one electron, right, because it's atomic number 1. So the hydrogen ion, when it loses that electron, guess what? It's just a proton by itself. Okay, so hydrogen ion here and a single proton are synonymous. So hydrochloric acid breaks up into hydrogen ion and the chloride ion. Okay, sulfuric acid, because it's got 2 hydrogens, it's going to break up into 2 hydrogen ions and the sulfate polyatomic ion. Now these first two guys here are what we call strong acids. They dissociate at 100%. Okay, so there's only a handful of acids that dissociate at 100%, so there's only a handful of strong acids. Most acids, including, I don't know, the thousands of weak acids that are in your body, are called weak acids. And they are in equilibrium. That's why we just learned about equilibrium, so we could understand acids and bases better. Which means they do not dissociate at 100%. Okay? It could be 5%, it could be 20%, it could be a lot less than that. Okay, so they tend to favor the reactants, and only a little bit of this here, okay, will dissociate into the hydrogen ion or the proton, and in this case here the cyanide ion. Okay, but acids dissociate in water. Okay, when you dissociate and you release only one proton, you're called monoprotic. Okay, so if you release more than one, like sulfuric acid, you're a polyprotic, and of course hydrocyanic acid there is monoprotic as well. Okay, let's talk about bases. I tell my students to remember the B's of bases. Bases are bitter, they turn litmus paper blue, and their pH is bigger than 7. Okay, lots of cleaning products, of course, not all things, but lots of cleaning products tend to be bases. Okay, typically, and we'll talk more about this later, they end in hydroxide. They have hydroxide in them. That's what part of what makes them a base. Okay, bases also dissociate in water. You can have a strong base like sodium hydroxide dissociating into the sodium ion and hydroxide ion, or a weak base like ammonium hydroxide. Okay, remember, your weak acids and bases are going to be in equilibrium, favoring the reactants. Your strong bases, they're one-way dissociation. Okay, they completely split up. And there are compounds with hydroxide, many of them, that are actually insoluble. They don't dissolve in water. Okay. Now let's talk about water. Water is neutral, right? It's got that pH of 7. Why is that? Okay. Well, if you think of H for acid and OH for base, it makes HOH or water, right? So water is actually called something that's amphoteric, which means it's both an acid and a base. Now what really happens in water is this, okay? It's not that water splits up like hydrogen and hydroxide. what happens is if you have two water molecules and they collide with each other, okay, because that'll happen because those liquid particles are moving, every so often that collision will be just right with enough force and the right angle for this to happen right here. You end up with one of these molecules gaining an extra hydrogen, okay, an extra proton, and then the other one is left as a hydroxide ion, okay. So this H3O plus ion is going to become very important for this unit, and we call it hydronium, okay? And then you have hydroxide. So don't mix them up, okay? Hydronium is H3O plus, and hydroxide is OH minus. So even a sample of pure water, okay, completely pure water with pH of perfectly 7 will have some hydronium in it and some hydroxide, okay? Now, the concentration of pure water, the hydronium in the pure water, is this right here, 1 times 10 to the negative 7 molar. And guess what? Hydroxide is exactly the same, because both of these came from water, right? So that's why water is neutral right here. We have an equal, pure water would be neutral. We have an equal concentration of hydronium and hydroxide ions, and the pH 7 comes from this exponent right here. And we'll talk more about how to calculate pH at a different time. I'm going to tell you here about that, but we're not going to calculate anything. So what happens if we put an acid in water? Okay, as we said, the HCl, right, it splits up into H plus Cl minus. But then this guy here joins, okay, that water molecule, and it makes H3O plus and Cl minus. Okay, so when you put an acid in water, you're going to get that H reacting with H2O, of the H from the acid reacting with the H2O, making H3O plus the anion over here. Okay, so hydronium and whatever the anion is. So what happens when I put this acid here in the water, I increase the concentration of hydronium. Okay, and that's why we get this number here, this negative number, to get closer to 0. Okay, so that's why the pH scale from 0 to 6.999999 is acidic, because we're getting closer to 0 with that exponent. Okay, and we'll talk more about how to calculate that later. You don't need to have a full grasp on that. Bases, however, do the opposite. They decrease the concentration of hydroniums. Okay, so your exponents here are going to get further away from 0. So 7 or above, okay, are going to be your bases. Okay, the P in pH means potential of hydrogen. Really, pH is the negative log of the concentration of hydronium. That's how we calculate pH. Now I know you guys are like, oh my gosh, logarithms, I hate logarithms. It will be so easy, like it will make a lot of sense, so I don't want you guys to freak out or stress out. It'll be super, super simple, I promise. And even if you are in geometry right now, you don't need to stress. This will not be hard, I promise, okay? So I gave you a ton of information. We're going to go back through all of this and break it all up into more details. I just wanted to expose you to all of it.